Hello, Subir. Hello. Hello, Mr. Sudhir. Yeah, Mr. Rajesh. Hello. Ponira. Gani. Bro. Yeah, Giant just ask him to check whether I'm visible, audible, etc. Yeah, yeah. No, no. You ask him to check whether mine is connected or voice is correct. Okay.
Is it audible? Good morning to all. Hello, is it audible?
Good morning, Miss.
Who is that? Good morning to all participants. A warm welcome for today's session. And as we know that today's session speaker is Y.N. Reddy sir. Now I invite G. Kavita to introduce about Y.N. Reddy sir.
Thank you, Deepthi. Good morning, Professor Y. Reddy, sir, and good morning to all my dear colleagues and participants. I am Kavita, mentor, Department of Mathematics. A warm welcome to all the participants for Day 3, 7th November 2020 a national webinar series on current trends in mathematics applications in engineering, organized by Department of Mathematics from Rajiv Gandhi University of Knowledge Technologies, RGKT, RK Valley. So today talk on treatment of nonlinear problems will be given by Professor Vayan Reddy sir. Let me say a few words about Professor Reddy sir. Now I would like to say some words about us sir. Professor Annala Narasimha Reddy sir has obtained MSc in 1982 from REC NIT Warangal and PhD in mathematics from the prestigious IIT Kanpur in 1986. He worked as a short-term visitor at Tripura, Bangalore, and served as a lecturer at BITS Pilani for 3 years, and at NIT Nagpur for 3 years. He has joined REC Warangal in 1992. Then he was elevated to the position of a professor in 2003. Professor Reddy, sir, pursued research in the area of numerical analysis and published 116 research papers in the reputed international journals. He has produced so far 12 PhDs and supervised over 35 master projects. He has visited USA and UK for presenting research papers in an international conference. He has conducted 8 STPs and conferences. He is a referee for 8 elsewhere and the other national journals. He is a member of Senate of NIT Nagpur and NIT Goa. He is a member of Board of Studies of NIT Allahabad and NIT Kurukshetra, NIT Nagpur, NIT Goa, OU, KU, JNTU Hyderabad, JNTU Kakinada, JNTU Anantapur, RGKT, and AOU and CUK. He is a life member of ISTE and ISTAM, APSMS and SMS. He was an advisor for Rajiv Vidya Mission for 3 years. He is an expert speaker for DST Inspire programs in the country. He has served the institute in several administrative positions like head of the mathematics department for two times. He also served as registrar for NIT Warangal for 2 times. He was awarded the Best Science Faculty Award in 2016. Sir, after hearing all this, I would like to say you are the inspiration for all of us. Thank you. Now I would like to invite our professor to start the session. Over to Professor Vayan Reddy, sir.
Thank you, Dr. Kavita. Thank you, all of you. It's a good thing that you started a wonderful webinar. Am I audible now?
Yes, sir. Yes, sir.
I thank personally all the organizing committee members for inviting me to this. You can ask others to mute so that it will be noticed. All others can please mute. Am I clear, madam?
That's it.
Yeah. See, my topic is a very interesting topic. It's called how do you handle the nonlinear equations? We, the teachers, are very clever. We teach good things in the class, and tough things we leave it to the students. And certainly students also leave it. But that's not the way to learn the things. How do you handle the nonlinear problems? The difficult thing in the world is the nonlinearity. The best example for nonlinear is our mind. Mind works in a nonlinear fashion. It works in an n-dimensional thinkings. At a time you can be excellent in thinking in non-dimensional things. Our so-called nonlinear problems are more toughest and more dangerous also. How do we handle the nonlinear problems? I'll take from the classroom what we generally live in the classroom. Simple things in the classroom. I'll start with the classroom so that everybody understands. Then take us to the things where certainly research is required. So the first few slides will be already known to you, maybe the teachers or even the non-students. It gives an idea where we start, why we start, and how we should think. And in fact, if you look at the syllabus, we teach very cleverly linear algebra. Maybe you don't know or they don't know, but it is because syllabus is there. You teach linear algebra, not only linear algebra, in the matrices, what we call it as. Moment I say linear algebra, you talk about matrices. That's all. That is the end of the story. That's all. You stop there. But that's not the end of the story. That is only beginning of the story. So the matrices, the linear algebra made your life simple. But that is not the real life. Non-linear things are there. Non-linear problems are there. How do you convert? How do you handle them non-linear problems? So my simple topic is from the classroom to the toughest research level, called how do you handle the non-linear problems? Problem, don't think that I'm talking about simple problems. Simple problem can be simply algebraic equations. Algebraic equations involving more variables, maybe differential equations, partial differential equations, integral equations. Problem can be anything. Problem can be algebraic, problem can be ordinary equation, problem can be in partial equation, problem can be integral equation. But the problems are two types, linear and non-linear. It's like, with the permission of the girls teacher, it's like males and females. That's how it is linear. There are vertical division among the problems. There are linear problems, there are non-linear problems. Fortunately, linear problems are very easy, dead easy. Linear problems are the simplest things in the world, but non-linear problems are very difficult. How do you handle the non-linear problems? So I'll start my presentation.
లేదా చెప్పనని చెప్తారా ప్లీజ్ డోంట్ మైండ్
The organizer can mute all except me. So yeah, can you see the presentation now? Please tell me. Kavita, is the PPT clear? Hello? Hello?
Clear, sir.
Yeah, well, can you tell me, read the title so that I can be confident?
Treatment of non-linear problems.
Okay, enough. See, this is starting few slides will be as if it is in the classroom, but then we'll move to the real reality, what we should do. Non-linear problems, which means there are certain linear problems. My objective of this lecture
Excuse me, your voice is not clear.
Yes? Voice is not clear? How do you convert non-linear problem as linear problem? Because linear problems are easy to handle, easy to solve. That is why you call it as linear algebra. BTech first year, even from 8th class onwards, matrices are taught. Whether you like it or not, linear algebra is there right from the 8th class. Solving equations, matrices, linear algebra is a fundamental course for any student, maybe BSc, BTech, or any graduates. But why? What's the problem? The non-linear problems. Non-linear problems are very difficult. It is impossible to even look at it. But you cannot leave it, no? You have to solve. You are a teacher. You have to handle them. And you are an educated person. We should not leave them. The non-linear problems are how to be handled. How do we treat the non-linear problems? What we do in the classroom is very, very simple, and without even telling them what is going on. Once you understand what is going on in the classroom, that is enough for us. The syllabus makers are clear. Teachers may not be clear, but the syllabus is very clear. If you study this much, you can do wonders in the world. That is exactly what we decide in the syllabus. When you say this much is enough, what do you mean by that? If you study this much, you can really do wonders. So if you know how to handle the linear, I think you can handle the non-linear as well. But how do you do it? We have done in the class, and that is exactly the simplest concept. So the main object of this lecture is how we convert a non-linear problem as linear. Remember, I'm not talking about only algebraic equations. I'm not talking about only different equations. I'm talking about the problems. It could be algebraic, could be differential, could be integral, could be anything in the world. Any problem which is a non-linear, how do you handle as solving non-linear problems? Because linear problems are easy. I'll tell you within 1 or 2 slides why it is so easy, and even anybody can solve it. You don't require, your teacher is not required to solve linear problems, but non-linear problems are more important. Problems are two types, clearly. Let's like males and females. Excellent division of the world. No, the human beings are divided into vertically, males and females. It's like this. All problems are clearly defined. Clear. There is no distinction. Clear, linear, non-linear. So vertical. How do you define? Let me take a simple algebraic equations. In a classroom, in 8th class, 9th class itself, we define Clearly, algebraic equation is supposed to be linear or non-linear. Some simplest definitions are, look at the degree. If the degree is 1, you call it as a linear. See x square, x cube, etc. See the power x power 1 or x power 2. I mean, immediately you say, look at the equation and say it is a linear equation or non-linear equation. So the simplest definition, right from the 8th class, 9th class, or any time now, the algebraic equations, if you talk about, it is clear by looking at the degree, the power, I can tell whether it is a linear or non-linear. If the degree is more than 1, it is non-linear, or it is not linear. This is the best way of defining. No? See, it is not linear means the degree is not 1. So it is not linear means non-linear. So the non-linear has come because of the word understanding. Should not call it as a not. Not is very something which is not acceptable in mathematics. One should not say not. One should say non. Non-linear is a popular thing, and linear is very clear. What do you mean by linear? Any equation in which variable degree is 1. Power is 1. Simple, that's all. So everybody knows, even 8th class fellow knows. But what is non-linear? Look at example. Suppose I have only one variable, simplest. Ax1 is equal to b. So I can always find what is the x1 in 8th class, 9th class, even 5th class boy can find out what is x1. Simplest thing now. Let me go for the 2 equations, 2 unknowns, 2 variables, they call it as find x1, x2. Then you need 2 equations. Ax1 plus bx2 plus cx1 plus dx2 is equal to alpha beta, and you can find out. You put substitution and then elimination. Some simple process, you can put 1 in 2, 2 in 1, or whatever you do it. I have no objection. You have seen such things. These are beautiful linear equations. So I have the linear equation with 1 variable, linear equation with the 2 variables. Why 2 variables? Once I go for 2, I can go for biggest big. Oh, I can find x1, x2, x3, xn from n equations. How are these n equations? So beautiful, no? a11 x1, a12 x2, and last one is an1 x1, like n xn. Well, assume that everything is beautiful. Let us not worry about this. No? Your question is to solve. Let us not quarrel about whether the solution exists or unique, etc. All known to you. I'm only worried about how things go. So this is the beautiful system. But fortunately, it is linear. Why it is linear? All of you know, nobody writes like these equations. Simply, sir, I don't write all these big things. No, I write most comfortable, most beautiful manner, because how many are there? How many unknowns are there? Many unknowns. First I started with 1 variable, 1 equation, 2 variables, 2 equations, 2 variables, and equations. I'm more comfortable. I'm confident than anybody in the world. You can solve, because my teachers taught me write it as a matrix problem. So if you have linear equations, even in many variables, no problem, simple, I can write as a matrix. Ax is equal to b. Matrices help us to solve the system. That's what we call linear algebra. That is the end of the story. Linear algebra helps you to solve only linear problems of 1 variable, 2 variable, or n variable. That is called linear algebra. But if it is non-linear, linear algebra cannot help you non-linear problems. End of the story. Oh, no. How can you say the end of the story? The progress is that. So you have to think about that. So if I have an equations, linear equations, simply Ax is equal to b, you talk about all beautiful things and you find out, start with Cramer's rule, Gauss method, or Reddy method, Rao method. So many methods are there, you can generate a method. So as far as the linear systems are concerned, simply things are beautiful. But unfortunately, what happens is you just go a step ahead. If the degree is not 1, if the non-linear problems are given to you, what do you mean non-linear? Degree is more than 1. Simplest example I can think about is ax square plus bx plus c is a very popular example, quadratic equation. But fortunately, somebody has helped me to find out that root of this ax square plus bx plus c minus b plus r minus etc. is easy. All of you can easily find out. I know it. Suppose the question is find x. So that first equation is given. You can find out. But what about second equation? Suppose if I give third cubic equation, most of you cannot find. I am sure about that. Maybe none of you. Why? Because, sir, you put x is equal to 1, 2, 3, 4, or minus 1, 2, 3, 4, and you get one thing and factorize it, etc. Okay, you may try if it is x cube, but if it is x power of 20, x power of 40, or x power n, polynomial of degree n, how do you find the x value? I don't think you can find out. Impossible. There is no way. Oh, but this is not linear. Oh, one variable only. With 1 variable, if the degree is more than 1, gone. Maybe fortunately you have for x square onwards you can find, but x cube, x 30, 40, 50, x power n. Why do you talk about polynomial? Take the next example, 2x minus e to the power of x. What is the degree here? Nobody knows. What is the degree? It is more than 100%. What about last example, sin x minus root x is equal to 0? All nonsense functions are coming, called transcendental structures. The most ugliest, I call most ugliest, not beautiful, most ugliest functions are sitting in the structure. They are the beautiful equations for nonlinear examples. But you cannot give up now. You have to solve. You have to find one root. Give me one root of the so-called. What is the value of the x solving this equation? Maybe one of them. No, you cannot find. Only the first one you can try because of the known thing minus b plus or minus b. But look at, I don't want to write it as the e to the power of x, or sin x, or root x, or all big things. In general, the nonlinear equation will be with one variable. With one variable, I'm talking about it. F of x is equal to 0. It's the most popular way of writing it. F of x is equal to 0. So it could be sine, root, e to the power of war, log, all nonsense things come. X power 20, x power, all nonsense root x. So it is going to be one equation only, for one variable only, but degree is not at all known. Not at all known. You can't say 30, 40, or even it is radical structures. But how do you find? You have to find. You know it. How do you know it? You know. How do you know? That's exactly. Now let me get, suppose if you have two variables, again the same story. I don't have any structure, no. I have only equations, unknowns. What are the unknowns here? X and Y. This is not simultaneous equations. So this is not algebraic equations. This is a beautiful, most powerful nonlinear equations. Looks beautiful, but it's not possible to find anybody. No, it is just impossible. How do you find X and Y? You can't eliminate. Why do you do it? No, you have to know how to find out nonlinear equations. One variable was simple, but now two variables. Why only example? You take general structure. It is going to be finding x and y such that f of xy is equal to 0, g of xy is equal to 0. How do you find x and y satisfying the two simultaneous equations? But unfortunately, these are non-linear. See, look at your x power 3, e to the power of x, cos y, sin y, all nonsense things can come into picture. Two equations required because two unknowns are there. One equation, one unknown. Two equations, two unknowns. Equations are non-linear. How do you solve? Now next, why only? Now take 3 and x, y, z. You have three equations. P is a function of x, y, z. Q is a function of x, y, z. R is a function of x, y, z. All nonsense structures are there. Three equations, three unknowns. But problem is highly non-linear. What do you mean by highly non-linear? You don't know the degree. If it is 2, 3, probably you do handle something, but it is totally sin x, cos x, root x, e to the power of x, log x, all nonsense transcendental structures come into picture. Not one variable, two variable, three variable. Why only three variables? Now I can go for a more general structure. I can have the n variables. I have the f1, x1, x2, x3, xn, f2, x1, x2, x3, xn, fn, x1, x2, xn. I have n variables, n equations, but non-linear. You cannot write as a algebra. You cannot write as a matrix form. Remember that. Do you remember? You don't think that you can write as a matrix structure. You cannot write this as a nonlinear equation, as a vector matrix form. For algebraic linear equations, you can write vector matrix form. For nonlinear equations, you cannot write vector matrix form. So then, linear algebra cannot help you. Over. Linear algebra, hence the end of the story in the first year itself. Matrices or linear algebra will not help us. Who will help us? Only I can help you. Only we can help you ourselves. So something is required. How do you solve them? Now the question comes. The problem is there. You can't solve. You already studied linear algebra for 1 year, full year. The question is, if you cannot solve it, what do? You convert. You convert linear equation as a linear equation. Now, how do you convert? Who will tell you how to convert? There is a great man called Newton. He helps you to find a linear equation for a non-linear structure. Any non-linear structure can be linearized. Call it as a quasi-linearization. Hence, now the topic starts. You have linear problems. You can write if one equation, two equation, three equation, any equation you can write is linear algebra. Ax is equal to b. But if you have the non-linear equation, one equation, two equation, three equations, or n variables, n equations, you cannot write as a linear algebra. You cannot write as a matrix. Non-linear equations will not be possible to write it as a vector matrix form. Hence, linear algebra or so-called matrices cannot help us. Then how do you do it? That's exactly the main question. If you see the most of things in mathematics, if you know the problem, answer is clear. Many times, question is not clear to many of the students. That's why I have defined what exactly I want to do. I want to convert any non-linear problem as a linear problem, because non-linear problem cannot be solved as such, cannot be written as a vector matrix form. But I know how to write a vector matrix form with linear equations. Can I not use the knowledge available through the linear algebra, through the matrices, through the study what I have done so far? How do I convert a non-linear problem as a linear problem? So the great man Newton helps, called it as a quasi-linearization. You can convert any non-linear problem as a linear problem. So again, beautiful. Now we'll see. You know it, but only thing is you don't know that. You know that. That's the problem. నీకు తెలుసు కానీ మర్చిపోయాం, అది పేరు మర్చిపోయాం, పేరు చెప్పండి. It is advantage of great teachers are we don't tell the what, why, how, etc. Simply because it is a syllabus you teach. But remember, we have already taught you how to convert a non-linear equation as a linear equation. Only thing is they might not have used the word how we converted. They might not even use the word conversion. They might not have even used the word quasi-linearization. They might not have used the word called converted non-linear to linear. But simply say you can solve non-linear equation. How is that? How? I mean, is it possible for a person to solve non-linear equation? Impossible. If they say you just take them to court. Impossible for any person to solve non-linear equation. Only thing is they by mistake they don't tell you, but they have converted a non-linear equation as a linear equation. Now I will reveal what we have studied. You know it. Only thing is you don't know that you know it. Nothing but finding a x such that f of x is equal to 0. That's all we have to find out. What do you mean by that? Some equation is there. What is the value of the x for which f of x is equal to 0? That is nothing but indirectly talking about a topic called, that is to find a root for the given nonlinear equation f of x is equal to 0. What is that? Somebody is, please help me, for what value of xi f of xi will be 0? So question has now become revealed. You know the answer. So what was the question now? How do you find x for a given nonlinear equation which is highly complicated single variable? Now that is nothing but finding a root of the nonlinear equation. Oh, that means you just simply find out for what value of xi f of xi will be 0. So some equation is given, put some xi. If it's 0, you are lucky. Xi is gone. That's exactly what we wanted. Oh, but how do you get it? Yes. We already studied. Our iterative methods call to do is start with some initial guess. I will tell you how to find an initial guess. This is some start. You always start something. Something you can always say. In the worst case, you start with some natural guess, then repeat repeatedly, then stop the process as in the two successive answers are same, or till you get a satisfactory answer. When you are satisfied, stop it. It is you to decide when to stop. It is an iterative process. You start with some initial guess. But the question is, how do you guess initially, sir? I don't know anything initial guess, sir. I don't know where the root is, sir. I don't know what value of the 2 or 3 or -2, -3. I don't know, sir. Oh, better you don't know. I will tell you. I will tell you mathematically how to start with even simple initial guess. If you know the initial guess, then people are ready to help you how to improve it. So guess something, improve it. So I think any iterative process, not learning itself is an iterative process. Every day you learn, start learning something, base 0, but you improve, become a professor, become an intelligent person by iterative methods, iteratively. And learning is a continuous process. Improvement is a continuous process. So start with initial guess and then improve further and further. How do you start with the initial guess? You all know it pretty well. How do you choose the initial guess? That means exactly where the root is. Where the point is. Oh, the main task is to find out the location of the interval, which can get the root. This is simply known to you. Some AB you can find out such that product of f of A and f of B is negative. This is done in the class for a BTech first year or anywhere even 10th class +2. So how do you find the root, location of the root is find out A and B such that f of A and f of B is negative. Then some great people helped you. There are gods and goddesses. They help you that there is an intermediate value theorem which guarantees, my dear friend, there is a root between A and B. Xi belongs to A and B, so such that phi of 0 to 0. So how do you start the initial guess? I know the interval. What is the interval? Find out A and B such that f of A and f of B are both of opposite sign, whatever you call it as. This is known to you in finding roots. Bisection method, regular false method, Newton-Raphson method, so many methods you have used it. So where that is exactly what we want. You want to find out the interval where the root lies. How do you find? Find A, B such that f of A, f of B are product is negative. Both are of opposite sign. Which is positive, which is negative, let us not quarrel. Product will be negative. Hence, immediately guaranteed there is a God promise that by intermediate value theorem, you guaranteed that xi belongs to in the interval A and B. Oh, if the interval is known to me, that means any interval I can then such starts. How do you find that xi? The only thing is you know where the xi is. But how do you find the xi? Oh, that means exactly what you call Newton-Raphson method. So bisection method, Newton-Raphson method, all methods are known. Let me take the Newton-Raphson method, very simple. What do you call it as? It was a non-linear equation. It was non-linear. There is no doubt about that. But where was the non-linearity comes to picture? Let me see now where the linearity has come into picture. So the given equation was non-linear. There is no doubt about that. We wanted to find out the xi is equal to f of xi is equal to 0. Then the job is to find out the interval f of A, f of B is negative. I could find out that. Put AB, AB, AB. Then you get the xi. The interval is very popular. Everybody knows. One thing is guaranteed. So I can start the journey. My rough guess, initial guess can be from the interval AB. It could be A or B or A plus B by 2 or any point belonging to A, B. It can be closed interval, doesn't matter much. Now, if you know the X naught, then what is the next step? How to improve? Particularly, you know it is not correct answer. X naught is not a correct answer. So I am directly going for Newton-Raphson method. Forget about the bisection regular fallacy. Newton-Raphson method is because I want to know how the Newton has done. Because I was having the nonlinear equation. He says he has solved it. How he has solved it? He must have converted nonlinear as a linear. That's what I want to trace it, where he has done it. Then improve it. How do you improve? You make it as x1, x2, x3, x4, x4. Keep on iteratively find out. Somewhere it goes to converges to the root xi. So x1, x2, x3, x4 n are obtained by Newton-Raphson method. So the Newton-Raphson method was meant for solving a nonlinear equation. I want to see where it has been linearized. See, by Taylor series, I can write it as f of x is equal to about a point. So the f of x is given to me. I write f of Taylor series about a function of x naught. I know pretty well f of x is equal to f at x naught plus x minus x naught, f dash x naught plus something. If any one of you are in a hurry or more clever than me, then you become fool. Because if I take next term, what happens? X minus x naught whole square. Oh. Square should not be taken. Moment you take square, it becomes a non-linear. I stop it here itself. I stop. That's exactly cleverness of the great Newton. Newton stopped at this place. When you stop it, becomes this much only. Oh, look at what is the degree of the x? 1 only. Linearized. First degree. Over linearized. Fx was beautifully non-linear and you made it as linear. What a great thinking. Whether you know it or not, it is linearized. This is exactly straight line or first degree equation. Simply linearized equation. Linear means degree 1. If I take one more term, you all know pretty well. Don't be in a hurry. If you are in a hurry, write one more term. And one more term will be x minus x naught whole square into f double dash by factorial 2. Oh, overaction neka. No, don't do that. You stop at this place, you are comfortable. If you write one more term, gone case. You may say, sir, this is harsh. This is very simple. This is very approximate. Yes. What is the problem? It's all done to you. You know it. Let me see. This is exactly what I want. So you see here, Newton has made it as a linearized. It is nothing but a linearization. That is, f of x was highly nonlinear. Now you replace it by a first degree curve. What in by first degree curve? X power 1 only. X naught is a number. F dash over x number. This is a number. This is a number. Simply, this is mx plus v form. So f of x is almost decided as mx plus c. So it is indirectly you have linearized the nonlinear equation. What a clever idea. Newton is a great man. Very simple way of teaching the great things. This was a nonlinear equation. There is no doubt about that. Nobody can find out the root of that. But Newton made it as more simple. My dear friend, I have linearized it as a linear equation. A nonlinear equation is linearized. What do you mean linearized? It is simply first degree equation. First degree equation means mx plus c, straight line, x is equal to power 1 only, no 2. If you take one more term, you are in trouble, you cannot. Then you will not be in our party. You are not in Newton party. You are in some other party, which is not possible to solve anywhere at all. So if you stop at this place, then you realize that it's going to be this much only. So so on is removed and make it as approximately equal to 0. So this much only, that is f of x is linearized, which means by replaced by a first degree curve or a straight line. That is exactly what we call f of x was highly nonlinear. Might have been involved in e to power of x, sin x, log x, all nonsense things are there. But by force, if you don't agree, there is no problem. But this is already done and accepted in the syllabus. So Newton has replaced the f of x by straight line or so-called first degree curve. Hence, I conclude Newton as nonlinear equation is converted by linear structure. A nonlinear equation is replaced by linear equation. So I can find out what is x is equal to here. What is x? That is exactly what you wanted. You wanted to find out x1, so I formulated it as x1 is equal to x0 plus some change in that. So I can find out fx1 is equal to approximately 0. So I again put it as 0. So I got the h value. So Newton-Raphson method helps you to say that all x1, x2, x3, 4, x1 are calculated. So this is going to be a simple way of Newton-Raphson method. But what has been done? A nonlinear equation has been linearized. This is exactly what we call it as a linearization of the nonlinear equation. So I'm not worried about the method. I'm only worried about how could he do it? How the nonlinear equation has become the linear. This is the simplest way of looking at it. It is now simply a nonlinear function has become a linear. Nonlinear function has become linear. Oh, that means I catch this. I catch this. That means if I have a nonlinear function, I can replace it by a linear. I have simply straight line, simply first degree curve. And then of course I can find out what is x1, x2, x3, x4. then I can find out the Newton-Raphson method. So let me make it as a one or two simple examples how you teach in a classroom. See, I always go for some interesting individual assignments. So because if you say assignments, people think that the assignments are copied. One fellow does and everybody copies. No, my assignment cannot be copied. Nobody can copy, nowhere it is available. So using Newton-Raphson method, find a square root of your rule number. Your rule number is unique. Nobody's rule number is like your number. Your rule number is unique. Any college, you have your rule number. What is the square root of your rule number? That number, let that be n. Now, to understand how to use a Newton-Raphson method, I need a function. Unless I have a function, I cannot find out. So let that root n is equal to x. So what you want? You want your rule number. N is your rule number. So you want to find out the square root of your n. That's nothing but x. Since I don't know what is the square root of n, let me make it as no. We don't know what is that square root of n. That's what I wanted to find out. So remove that square business. How do you remove the square business? You remove it. Make it square both sides. I become the n is equal to x square. So since I want to find out the square root of n, I don't know what is the square root of n, I square it. Then I get x square is equal to n. Oh, I got the function. X square minus n is equal to 0. This is the function. If this is the function, my job would starts. So what do you require for the Newton-Raphson method? I need f dash. So formula is this. Xn plus 1 is equal to xn minus f of xn by f dash xn. So I dump everything and this is the equation. So the simplest way of assignment for any individual student, let it be Idupulapaya or IT or NIT. The assignment is unique. Nobody can copy. You have your own rule number. Find the square root of your rule number. Your rule number is unique, so you cannot copy. Your answer cannot be equal to anybody's answer. So hence individual assignments are there. Now that means if there are 1,000 students, 1,000 assignments are individual because their numbers are different. They have to find out. They cannot copy from anywhere. This scheme can be copied. Scheme anyway is available in the book, but number is your number. Once you put your number, everything gets changed. So your answer will be different. So this is what we call it. How do you use the Newton-Raphson method to find out the square root of your rule number? Why only square root? You can find out the cube root of your rule number. Beautiful. Another assignment. One more assignment. All the students can take up it as a challenge. Find the square root, cube root of your rule number. So square root is there. If you can find out square root, you can find out cube root. What do you mean by that? Oh, I want to find out the cube root of n. That is nothing. But let put set anukonomo, x anukonomo. So then what you call, I don't know what is the cube root of n. I make it as a both sides cube, x cube minus n is equal to 0. This is a function. So if this is a function, I can find out what is the f dash and then write down and then I got the answer. So this is also interesting assignment for everybody, individual assignment. What is the cube root of your rule number? Your rule number may be 4-digit number, 5-digit number, doesn't matter. It's a computer doing. So your answer will be individual. You cannot copy, and this is the most online education. This is the easiest way of giving assignments. What is the square root of your rule number? What is the cube root of your rule number? Why only this? One more. Yes, is the mth root of your rule number. Mth root, square root, cube root, then mth root. What is mth root? Okay, you say your friend is number is 14th root of your rule number. If you say your friend is 99th root of your rule number. So take two people number. So one is your rule number, another is your friend's number. So your friend number is 20, then say 20th root of your rule number. So you can make it more glamorous that you can find anything in the world. That's a great thing. Though it is non-linear, highly functional. So I can call it as the square root of mth root of n is equal to m, and then come both sides to power m, and this is the equation. So these are the simple examples where we say any non-linear equation is cleverly solved. Cleverly, cube root, square root, any mth root. Mth root is maybe your friend number 40. So 40th root of number 4. Yes, no problem at all. I can find out 40th root of 54, 54th root of 44. So that's exactly what we call mth root of. Last, suppose if you have to find out inverse of your number. Your number is say 49. What is 1 by 49? You don't use a calculator, no. So use the Newton-Raphson method. How do you find the inverse of your rule number? Your rule number only. All assignments are individual. So find, how do you find the inverse of your rule number? Your rule number say 49. What is a 1 by 49? There is no calculator. Tell me what is the Newton-Raphson method. Because you could find out square root, cube root, mth root. Then you should find out the inverse also. Yes, that's exactly what we want. So let that be 1 by n you want. N is a big number. Maybe some people number is a 4-digit number, 5-digit number. So what is a 1 by n? Let that be x. Now immediately you say nx minus 1 is equal to 0. You multiply, cross multiply. And now this function, if you take, unfortunately what happens, if you take f dash, it becomes n. When you start with any interval, so you always know how to solve that is the big thing. So hence scheme becomes 1 by n. So that means what is the choice of the function? If I choose this function fx is equal to nx minus 1, how do you get the nx minus 1? Because I was only interested in finding the square root, the cube root, mth root. I could do it very fast because I wanted to find the function. Now the function is important. So how do you find the function? Oh, I thought nx minus 1 is equal to 0. No, it will not help you. This is the wrong choice. You should not choose fx is equal to nx minus 1. Because if you choose that, f dash is equal to n, and then substitute that, you get 1 by n. But if you wanted to find out why 1 by n, you are asking 1 by n. But this is illogical. I am asking you to find out what is 1 by n. You are asking me, sir, give me value of 1 by n. Then why should I ask? So what you wanted to find out? 1 by n. What are you asking me? 1 by n. So hence it is not acceptable. So this function is wrong choice. What is the next choice? Sir, 1 by n can be nx. Then can I take this way? Oh, this can be the best way. X minus 1 by n. Oh, let me try. So this is the structure. I have the structure here. 1 by n is equal to x. Or 1 by n is equal to x. So one option is nx minus 1 is equal to 0. Another option is bring 1 both sides. X minus 1 by n. Now if I go for the derivative, what happens? Derivative is 1 by n, and substitute, and again 1 by n. These are the two bogus options. See, if students do it in hurry, they'll land up in trouble. So you should be very clever. What should be the function of x? Fx should be chosen cleverly. Otherwise, you are in trouble. You are asking me what is 1 by n. So if you are asking me 1 by n, what was the question? I asked you to tell me what is 1 by n. You are asking me what is 1 by n. So question answer cannot be answered. So hence, these two are wrong choices. What is the best choice then? This is the best choice you can say. So 1 by n is equal to x should be what I have done for the square root, what I have done for the cube root, we should do that. So here the power n power 1 power should be written as minus 1. That is the most beautiful way of writing in mathematics. Instead of writing 1 by n, we always write cleverly mathematics n power minus 1. Oh, that means you don't know what is n power minus 1. What do you do then? Since we don't know what is n power minus 1, we should make it as remove that. How do you remove? Multiply. So you make it as, so square it, cube it, then m power done. Now I do inverse structure. I send that power to this side. So I can put it as 1 by x is equal to, so I call it x idhar aayega, n idhar jayega. So 1 by x is equal to n, that is the best choice. So I put n is equal to x power minus 1. Oh, that means n is equal to 1 by x. Oh, this is the best choice. Oh, this is the best choice. How do you say it is the best choice? Let me take what is f dash. I get minus 1 by x square. And start with some initial value, put it in the scheme. I land up with a simple structure of this. This is the only choice of the function when you want to find out the inverse of your whole number. Wherever the square root, there is no difficulty. Square root, there is no difficulty. Root, there is no difficulty. What you do is you send the difficulty thing this side. You wanted to find out the square root, you send that this side. If you wanted to find the cube root, you send that this side. Who has come to here? Now similarly, mth root, you should m is comes. The same story with the m. Should be, so these two are wrong choices. So many times you misunderstand that any function, no, any function will not help. Only the appropriate function is the power of that n should come to x. So the logic was, what was the power of n? That power was converted to x square, x cube, x power m. We did it. Then I should do that also. X power n power minus 1 should come to x power minus 1. So I have that's exactly what called n is equal to 1 by x. So the function must be this only. So if I take this as a function, then I see what is f dash. Then I put everything in this function. So I get the x n plus 1 is equal to, this is the best choice of the function to find out the inverse of your roll number. Very popular question. This has come several times in GATE exam. How do you find the square root inverse of your roll number? Because if I check this, whether this is the right function, option choice 1, choice 2, choice 3. So multiple choice questions. What is the appropriate function for finding the inverse of a rule number n? So first choice, second choice are wrong, third choice is the correct, fourth choice will be none of the above. So like that we can give beautiful examples. Now we extend it slowly. Now we learn better. Now if there are two equations, two unknowns, how do you do it? Oh, so far I was enjoying only f of x is equal to 0. Now I have f of x comma y is equal to 0, g of x comma. My job is to find out what is the root, but now not single root. There are two, one for f, one for g, one for x, one for y. All big things are coming to picture. My job is only to extend it. There are two equations, two unknowns. Unfortunately, you cannot write it as a matrix problem. It's not a matrix problem. Non-linear cannot be matrix problem. But I want to convert it to non-linear as linear. Now see, drama starts. Now expansion now clearly says how Newton has done. I will do it now. So what? Suppose I want to find out what are the values of the x and y. So that these two equations are satisfied. I start with some x naught, y naught. So remember, these are non-linear. How do you convert these are non-linear as a linear? How do you do it? Exactly what he has done there. If you have one equation, you convert it as a by Taylor series expansion. I convert it as Taylor series expansion. I want to find out x1, y1, x0 plus h, x1 plus h, and this is going to be a structure. So function of two variables, f of x0 plus h, y0 plus k, g of x0 plus h, y0 plus k. This is going to be function of two variables. Now I know how to write down the Taylor series for the function of two variables. So I write down f at x naught y naught plus h into dou f by dou x at x naught y naught plus k into dou f by dou y at x naught y naught plus one more term. Now I am very clever. I don't want to take one more term. If I take one more term, what will happen? H square will come. K square will come. No, I cannot handle squares. See, my job is to convert to linear. Everywhere degree must be one only. If I get the square, I kill that fellow. I stop that fellow. So I have written as a function of two variables. I write it as now the two equations, two unknowns. What is it you want to find out? H and k. Two equations, two unknowns. H and k are available. These are the two equations, two unknowns. I find for h and k, and these are getting the x1, y1 are available. So hence answer is available. If there are two equations, two unknowns, function of non-linears, no, these two are highly non-linear, more dangerous structures. But I can linearize. How do you do linearize? This is exactly use the Taylor's expansion function of two variables, because he has used only function of one variable. Once he has used a function of one variable, and then backward. This is the Taylor's expansion function of one variable. I can extend for two variables. I can extend for now. Why only two variables? I can even go for three variables. I can go for three variables. I can have the p xyz, q xyz, r xyz. So find out these three roots for the x1, y1, and z. So for I have to find out the answer, what should be the value of x, what should be the value of y, what should be the value of z, such that p is equal to 0, q is equal to 0, r is equal to 0. Three simultaneous nonlinear equations. It is just not possible for any human being to solve. But what you convert into linear, you expand by Taylor series expansion. You will have three equations. Stop at a comfortable place. Hence I get it as. See, the concept is same. What we have not told the students is a nonlinear equation was linearized. That's all. If you tell that, whether it is one equation or two equations, three equations, 100 equations, I don't care. Because any nonlinear equation can be linearized. Once I know that, how do you linearize? You may only say, sir, you are killing like anything. Yes, you are already allowed. How did you allow? In the one equation itself, you allowed. When you write for one variable, there was no problem for any one of you. You are all comfortable when I say f of x1 is equal to f of x0 plus h into f dash x0, put stop. Moment I stop here, why you are not asking? Because moment I take one more term, it is going to be h square. I don't want to see square business at all. Square onwards, it becomes non-linear. There is no doubt about that. Moment degree is more than one, it is going to be non-linear. I have made it as a linear by Taylor series. Well, whether you call it a why call it as a Newton? No, Newton observed by using the Taylors. Don't say that Taylor's has given the answer. No, Taylor has not said linearization. Newton advantage is that he knows the things. He has put it simplest way. Taylor knows. Taylor series expansion is known. Maclaurin series is known. You all know that. But what they never said you convert into conversion. No. What they say is any function can be written as a Maclaurin series, a Taylor series. But Newton has observed any nonlinear function can be linearized by taking only one term, two term, like that. So he knows how to stop. That is the greatness of the Newton. He observed that a nonlinear equation can be linearized by simply making a Taylor series expansion. Then, sir, anybody could have done it. Then nobody has done it. That's what the greatness of the Newton. Apple was falling every time, every year, every day before they even born. But only he observed that why it is falling. Now he says f of x is non-linear. I could make it as a linear. I could make it as a linear simply mx plus c. Once it is a one variable, no problem. Two variables, no problem. Three variables, no problem. I can write it as a two variable also. So if the two variables, two equations, I can convert it. I can make it as a Taylor series expansion for two variables. That is known to you. Function of two variables, Taylor series expansion is known in partial differentiation. It is popular. Or derivatives, ordinary, somewhere you study how do you write Taylor series for function of two variables. If you study for two variables, it is as good as studying for three variables, or as good as studying for n variables. So if you have functions of two variables, that means f is a function of x and y, g is a function of x and y. Both are non-linear, highly non-linear. But you can make it as a linear by simply making it as Taylor series expansion, stop at comfortable time. As he stopped there, he did not allow h square to come into picture. Moment h square comes, you are in trouble. What you are already in trouble, you are only making your life simpler. So you are replacing, you are approximating. When I say approximation, no problem. If you say, sir, you are killing like anything, there is no option. There is no option. Even if you agree for one variable, you should agree for two variables. So two equations, two unknowns, h and k are available. So the Taylor series helps you to find out the Taylor series for the function of two variables. Hence, become the two equations, two unknowns. Dou f by dou x, dou f by dou y, dou g by dou x, dou g by dou y. They're all numbers that dead bodies evaluated at a particular point. So some number into this, some number h and k are two equations, two unknowns. You can find out h and k. So I get the x1, y1. So I get improved. So Newton-Raphson method can be extended for a function of two variables. There are two equations, two system, what you call it as simultaneous system of nonlinear equations. But again, the concept is same. You have unknowingly made it as a linearized. That is the greatness of that. Now, if you have three equations, no problem. Now I am expert. Whether it is 2, 3, 4, any number of equations, you can convert linearization. How do you convert into linearization? So I call it as a PQR, function of three variables. Function of three variables, I can easily find out the Taylor series expansion. Again, I stop at this place only. I don't take h square, k square, or h into k, all nonsense things I don't like. See, the question is, how do you make your life simple? Newton is a great mathematician. He knows how to make your life simple rather than his life simple. He tried his level best to find out how do you convert a non-linear equation as a linear structure. So now you have only three linear equations, three linear unknowns. So you have the h and k, l. So three equations, three unknowns. Again, you can find out the h and k. So all the three variables are obtained by three equations. So the moment you have a non-linear equation, you can easily convert into linear structures. If you have one equation, no problem. Popularly known as Newton-Raphson method only. Only thing is, maybe if somebody has told you this, very good. But that is a concept. Concept is, how do you find a linear structure for a given non-linear function? It is Maclaurin series, you call it as Taylor series, you call it as, some series expansion, call it a it doesn't matter much. Name is not important, but observation is where to stop, how to stop, when to stop. When Newton is a very clever man. He stopped at a comfortable place, convert it as a linear structure. Any function can be replaced by approximating a linear function, which is nothing but a linear problem. A non-linear problem is replaced by a first degree curve or straight line, nothing but in mathematical words, if we use the term conclusion is, I am now comfortable. I can convert any non-linear problem as linear problem. I can always make it a more glamorous statement as I can make any non-linear function f of x is replaced by this. You may say, sir, you should take one more term, otherwise it is very harsh. I never said I am liberal, I am good. I have never said that, but I am saying this is the only thing I can make you a linear structure. If you take one more term, you are going to be in trouble. Once you are in trouble, you cannot solve it. If you are having problem, you were not able to do anything, hence you wanted an help me, and Newton helped that any non-linear function can be replaced by a simple straight line. Sir, this is not correct. No, who said it is not correct? There is no way. This is the only way you to find out the linearization of the non-linear function. And and this is a concept already done in the BTech level, first year level. Now we expand concept to the function of two variables. Function of two variables is same as that. So you have expanded the function by Taylor series by the function of two variables. So you could do it. This function of three variables. Yes, I could do it. I can do Taylor's expansion for three variable function, four variable function, and variable function. Taylor series is a simply expansion. You write comfortably as many times as possible. Stop at comfortable place. What is a comfortable place? To see that only power is one. Moment h square comes into picture, cut off, die, don't write. Harshly you put a full stop. So if I put a full stop, becomes algebraic equations. Now see, a non-linear equation has become a linear system algebraic equation. So Ax is going to be now helps me. Linear algebra helps. See, the spirit is, how do I solve a non-linear problem using my linear algebra knowledge? Because teachers taught me my linear algebra matrices right from the 8th class onwards, because everything in the world is going to be one matrix only. Even if it is a non-linear problem, my dear friend, it is going to be linearized. So it is enough if you can find out a linear system X is going to be. If you know something about the matrices, you can do wonders. But now we expand this. This is already known in the syllabus. What about the differential equations? Or how do I extend this into differential equations? Remember, there is a principle called superposition principle. For the teachers, it is very important. There is a superposition principle called, if you have the independent solutions, then whether the linear combination is a solution, that is the principle is popularly known as, if you have for a given problem, if there are independent solutions, it is possible when you give a problem to solution students, there are 100 students will give 100 solutions because they're all intelligents. Assume that they are all intelligents like us. So if there are 100 solutions, whether the combination of them is a solution or not, if the linear combination is also a solution, then the problem is called linear. If it is not, it is called non-linear. Simplest definition, what we call in mathematics, a quiz question or an interview question, define linear, non-linear. In algebraic equation, you could say that, sir, see the degree and answer. No, I'm not told you about algebraic equation. I'm just saying, suppose there is a linear problem, non-linear problem. I don't know what sort of problem it is. Let us not quarrel. It could be algebraic equation, could be differential equation, could be integral equation, etc., etc. So if we have some understanding about that globalization, bit bigger and bigger thinking. If the linear combination of the individual solutions is also a solution, then the problem is called linear. Otherwise, not linear. So this is the best definition than the looking at the degree. Because sometimes you cannot see the degree and you cannot, unless I give equation, you cannot say whether the problem is linear or non-linear. But I want to know whether the problem is linear or non-linear in a global sense. That is, a problem is said to be linear if the linear combination of the solutions. What are the solutions? Sir, there are 100 students in the class and everybody is giving answer. All answers are really correct. Correct is possible. There are many solutions for a given problem. It is possible that you all know for a given problem, there could be many solutions. So the 100 students have given 100 solutions. Now combine them. When you take a linear combination of them, C1S1 plus C2 S2 plus C3 S1 S2 S3 are solutions. Is the linear combination a solution? If yes, it is called linear. If not, it is called non-linear. So beautiful way of defining the superposition principle is, if you have for a given problem, I have not defined what is a problem. I'm going to define next class slide. If you have a problem, if there are independent solutions, how do you say independent solutions? Sir, my students are great. They're all independent. They don't copy. They don't take copy from others. They are all given the independent solutions. All solutions are satisfying, sir. What to do? Just check. Put all of them in the solution. Is it a solution? If it is, then linear. If it is not, non-linear. The best definition called, how do you define a problem as a linear, non-linear? My popular question in the interview is, how do you define a linear, non-linear? Superposition principle, if it is true, it is called linear. Otherwise, not linear. What is the superposition principle? If there are independent solutions, then linear combination of them, is it a solution or not? If it is a solution of the problem, then it's called linear. Otherwise, not linear. So a simple definition, popular definition called superposition principle. You can put on Google and get it. Now come to the specific task. Suppose if you have only differential equation. Yes, you have again the linear line. As I told you, anything in the world, always vertical division like males and females. Differential equations are vertically divided, linear and non-linear. How do you define non-linear and linear in the differential equations is also a popular question in the interview. Degree of the dependent variable. If the dependent variable is y, you look at only y. And its derivatives, y dash, y double dash. If the degree of the dependent variable and the derivative is 1, and they are not multiplied together, these two conditions are satisfied. If these two conditions are satisfied, the equation is going to be linear. What is the structure? You have a restriction that the degree of the dependent variable and the derivative should have power 1 only, and they should not be multiplied together in any rational manner. So after making it more glamorous equation, you see that these two conditions are satisfied. So look at the equation. If the degree is more than 1, you say it is not linear. If they are multiplied together, it is not linear. That's all the simplest way of looking at and telling you. Simplest way of telling whether it is linear or non-linear. So a non-linear is nothing but any violation of the linearity, it becomes a non-linear. There is no specific definition for non-linear. What is the definition of the non-linear? If it is not a linear one, it is automatically non-linear. So a very clever way of defining. Mathematicians are very clever. So we don't define non-linear. What we say is define linear. How do you say define linear? Sir, degree must be 1, sir. For whom? Dependent variable and derivatives. Then they should not be multiplied, sir. Then okay, if these two conditions are satisfied, linear. Any violation? Non-linear. Oh, beautiful. So the clever definition of non-linear is any violation of these, even if one of them is violated, the product is there. Let me take an example. Look at here examples. Examples of first order equations I'm talking about. So linear because there is a y is a dependent variable. There is a degree is 1, degree is 1, degree is 1, degree is 1. So these are all linear equations. X power can be anything. Independent variable can be anything. No restriction on the x. Independent variable. Name itself is independent. How do I control? In an independent India, independent person, independent system, nobody can control. So x can be anything. Only thing I am worried about the dependent variable. What is dependent variable? Y. Y should not have degree more than 1. Oh, all these equations are beautiful first order equations, but linear. What do you mean non-linear? Any violation. What is a violation? Sir, degree 2. Oh, non-linear. Sir, multiplied, oh, this is non-linear. Sir, e to the power of x, oh, it's highly dangerous non-linear. Because e to the power of theta, I know what is the e to the power of theta. 1 plus theta square, theta cube, etc., etc. Nonsense comes into picture. The denominator also. So e to the power of x is a big expansion. E to the power of theta like that. So e to the power of sine, log, cos, all nonsense things can come into picture. So if the degree is more than 1, multiplied together, these are all non-linear. Non-linear first order equations. These are linear equations. So there is a clear definition and a clear understanding how non-linear equations are there, how linear equations are there. When you look at this equation, when you want to look at the linearity, look at only dependent variable. Don't look at x. X can be anything. X can be 30 or 40 or 3, doesn't matter. Or if not, there also no problem. But e to the power of x, no problem. But I'm only worried about what is the degree of y. Y degree should not be more than 1. Derivative should not be all derivatives. Not only y derivative also should not be degree more than 1. And they should not be multiplied. So this is a violation here. Oh, y square is there, non-linear. Multiplied by one of them. So y and y dash multiplied, non-linear. Here e to the power of y is there, non-linear. Now I am clear and clever how the linear equations are, how the non-linear equations are. But let me go for the more general structure. How I study in a first year mathematics. How do you do it? Any general equation is written as y dash plus p into y is equal to q. Very popular structure of the linear equation. This is the most popular equation called general structure. Though I have given examples. So degree of y is 1, degree of y dash is equal to 1. So easy to say that it is easy. Oh, it's a standard equation. I can make it as a more general linear first order. What about non-linear? It is all structures are there. It could be y square, y cube, or nonsense multiplied by e to the power of all structures are there. So hence these are the non-linear. See the first order equation itself. You know what is a linear, what is a non-linear. Let me go for the second order equations. Second order equations, again the same story. Look at only y dash, y double dash. If they are degree 1, beautiful, beautiful, beautiful. Degree is 1, not multiplied together. These are all 3 are linear. But look at these 3. Oh, y square, sir, though it is second order, but you see here y square is there, hence it is non-linear. So product is there, non-linear. E to the power of y is there, non-linear. So I know by looking at the equation, linear, non-linear is very clever. So superposition principle or definition of the linear, non-linear, I only look at the derivative and the function, whether the degree is 1 or multiplied together or not. If their degree is more than 1 or multiplied, that is violation of the definition, hence I say going to be non-linear. How do you convert non-linear to linear? What is beautiful. See where we started. Where we started was the simplest algebraic equation. A simple algebraic equation started. Now we are going to do the wonderful research. How do you convert? Take it for granted. Any one of you teacher or great teacher or PhD teacher, impossible for any human being to solve these equations. Impossible for any person to solve non-linear differential equation. I can take a challenge as impossible for any person to solve this non-linear equation. What about linear? Linear, any fool can solve. So now the question is, how do you solve non-linear? Now you said, sir, Taylor tells you, Taylor is a person who helps everybody. Yes, he will help you. Just do puja and take prayer him, make Newton 3 times. Newton will come and say, okay, this non-linear problem can be converted as linear problem. What a great thing. Not only algebraic equations, anywhere non-linear problem, I will help you because Newton is such a great man. He helps you. You are in trouble. Why you are in trouble? Sir, the non-linearity. You cannot write auxiliary equation, my dear friend, young friend, any BTech fellow can see. You can write auxiliary equation for this. You cannot write auxiliary equation for this. There is no complementary function. Impossible. Might have told you, teachers have told you that no non-linearity in the class. Neither in the class nor in the life. For the teacher for some. No, but you cannot give up. No. Now Newton says teachers are always like that. No. I will tell you how to convert non-linear as a linear. They only teach you linear problems because they know that much only. Linear equations are simple things in the classroom. Tough things. They say out of syllabus. How can it be out of syllabus? Can you not look at it? No, let us look at it. That is exactly what we call research. Think big. See, teachers teach little things. In a classroom, you cannot do everything. So they say, okay, linear problem can be converted as, oh, now if I say a non-linear problem can be converted as linear, then enough. So what your teacher taught is sufficient for me. See, if I can convert a non-linear problem as linear problems, then job is over. My question is that only. How do I convert a non-linear problem as a linear problem? Because linear problems any fool can do. I'm saying really fool. Anybody can find out what is auxiliary equation. M square plus m plus 1 is equal to 0. Auxiliary equation roots are there. Roots complex, repeated. All nonsense things are simple. But if it is non-linear, nobody can write what is auxiliary equation. If anybody writes as m square plus m plus, what is this? Y square? Oh. You cannot write auxiliary equation. Then I will say, no, can you say it is out of syllabus? No. There is a Newton. You are unfortunately got this equation. Don't say printing mistake. It is a natural problem. What about this? Product is there. What is auxiliary equation? No auxiliary equation is available. No auxiliary equation. If there is no auxiliary equation, you cannot find out the complementary function. Gone case, I'm taking simple structures only, so that the difficulty of the nonlinearity is to be understood first. Moment you understand what is the difficulty in nonlinearity, then you say, sir, let us do the prayer to the Newton. Let the Newton come and help how to convert a nonlinear problem as a linear problem. Any linear problem anybody can find. That's why your teachers are very great. They take 100 examples from solved books only. So they take all nonsense examples and say all particular integral they can find all complementary functions. They can even go for higher order equations and say roots can be updated. But remember, if it is linear, their theory is valid. If it is non-linear, they will say out of syllabus. No. You say, sir, out of syllabus. Then let us do something that is called project work or called research work. Exactly. Now we discuss how do you convert a linear equation and non-linear equation. What is the link between them? So the most general structure of the linear equation is this. A linear second order equation looks like this. So degree 1, second order. Could be third order, fourth order also. Any order doesn't matter much. I am now clear about what is a linearity, what is a non-linearity. If I have a non-linear differential equation, how do I convert? So these are the two structures to be remembered. Second one is called a non-linear. First one is called a linear. Why? How can you say linear, sir? Degree is clearly one, sir. Degree of the y dash, y double dash. This is the most popular equation called the general linear second order. What about a non-linear? This is a more general non-linear equation. My job within 5 minutes, not even 5 minutes, over now, coming to the conclusion, great resolution or wonderful research. What an excellent idea. Why it is not included in syllabus, I really don't understand. I don't understand why it is not taught to be, why it should not be taught to the students. Teachers should not hide the things. Teachers should transmit everything to the students, so that, because tomorrow generation is going to face the world. My job is over. So teachers are old teachers are over now. Young students should know why not? Can I not convert non-linear into linear? If you can convert non-linear into linear, job is over. But we say not in the syllabus, not possible. No. It is possible to convert a non-linear. When you could do for algebraic equations, you never said it is not possible in algebraic equations. You said the Newton has helped you. Newton-Raphson method helped you. Then secondly, the two variable extended, the three variable extended. Oh, that means it is in principle we agree that any non-linear problem can be converted to linear problem. Once you accept that, first of all, you should remove from your mind, sir, conversion is something wrong. No. There is no way. You have to update yourself. You have to transform yourself. You have to change yourself. Changing, nothing wrong in that, because there is no option. If you can solve nonlinear, if your teacher says how do you solve nonlinear, I have no objection. But he doesn't know. If he doesn't know, then let us do something. Ask some big people, great people. Go for Bhagwan, called as research. In fact, olden days research goes to like anybody who does tapasya, where they used to go to Himalayas. They used to go to some forests and then sit for some time. Bodhi Vriksha, then sit for some time, prayer, then they get knowledge. That's exactly what we should do. Your teacher is not helping, what is that you can do? Forget about teacher. Go to some place, take rest, sleep, deep sleep. You get the idea. A non-linear problem can be linearized as we have done for the simple algebraic equation. I could do for one variable, I could do for two variable, I could do for three variable in algebraic equations. Why not possible for the simply a differential equation? It is possible for a non-linear problem to become a linear problem. Now, first of all, I should know what is a non-linear structure and linear structure. This is the linear structure. The most general linear structure of the differential equation is this. I can easily convert any nonlinear problem as linear by simply following what he has done so far. Now the question now starts. What I have done so far is already known to you. I now start. It's a PhD thesis of one single person, not a joke. It is a PhD work of the one person. Name thesis called quasi-linearization. How do you convert a non-linear equation as a linear equation? So question is very clear. Questions are very simple and answers are very trivial. That is, they present it. How do I convert a non-linear equation as linear equation? Now I know what this is given. I have to convert it to this. So beautiful. What was the way you are done in the Newton-Raphson method? Newton was very clever. He says you start with something. What is something? Okay, something. Oh, something from interval you started there. Now the same thing you do it here. Sir, let us start with something. It's an iterative method again. You already know that. Iterative method, Newton-Raphson method is iterative method. So we start with some initial solution. What do you mean initial solution? Let us suppose some initial conditions are given. So y naught is some ax and x plus c. So then the conditions are, remember, since it is a second order equation, There will be two conditions, not more than two, not less than two. Mandatory two conditions only. There could be initial conditions or boundary conditions. Let us not quarrel. What sort of conditions are there? Second order equation must be accompanied by two conditions. Once two conditions are there, that those conditions are y of a is equal to alpha, y of b is equal to beta. I'm taking only differential conditions, the boundary problem, nothing. You don't have to be specific about why these conditions only. Two conditions are given. When I take two conditions and I'm guessing what could be my initial guess. Initial guess is, remember, your solution must satisfy conditions also and differential equation also. So I start with initial guess. We start with initial solution y naught x as simply a straight line. I find M and C such that these two conditions are satisfied. So I find the M and C such that these two conditions are satisfied. So it's not a big thing to start. In the worst case, you take zero. I have no objection, sir. If you say, sir, my initial case is I am not able to do anything. I start with zero. No problem. Only thing is, if you start from zero, you take 2 days time to reach answer. If somebody starts from 1, you take 1 day to reach the answer. If somebody starts better answer, initial guess, if your initial guess is better, you reach the answer, you reach the designation and the destination fastest manner. So initial guess can be random or maybe scientific based or maybe somebody help or maybe by intuition, whatever nonsense you have it. So you can always find out initial guess by some satisfying initial conditions or boundary conditions or given conditions. So y naught is the initial guess. So like you have the x naught in the net adaptation method, you also have a y naught. Only thing is there it was only algebraic equation. Now it's a differential equation. So solution, y naught is a function, y naught x. Now what is it? There also you said x naught is not happy. You have to go for x1, x2, x3, x4 and keep doing it. Same thing I will do. I want to find out the y1, x, y2, x, y3, x, y4, x such that convert this to yx. See, same thing I'm repeating what I have done for the algebraic equation, Newton-Raphson method. There it was only x naught. I have you all know how to choose x naught. You find out a and b such that the interval contains the rule. Then pick up 1 point from there. Now the same story. I pick up one solution y naught x, then keep improving y1, y2, y3, y4, yn, and certainly guarantees that goes to yx because I'm going to give the conditions also. Under what conditions the sequence converges. So the same story there, same story here. So without going to theory, but one thing is philosophically, I want to find out a non-linear problem as a linear problem. So what I do, I start with initial guess, y naught x is equal to mx plus c. There is no difficulty. If you say, sir, I am not able to find out m and c, put 0, no, I have no problem. So initial value can be 0. There is no doubt about that. But one thing is you need more days time to reach the final answer. Somebody starts with a better answer. If your initial guess is correct, better, then you reach the answer fastest manner. Rate of convergence only. Otherwise, there is no big deal about that. So if somebody can be very clever, so he can start with a better initial guess. See, it's like something like, what is the cost of a saree? So you say boys will tell not correct, girls will tell correct. It doesn't matter. Keep improving. Somebody says 200 rupees, somebody says 4,000 rupees. Then you say, no, correct. Improve it. Then they get the answer. So initial guess can be wrong. Nothing wrong with that. But only thing is, if you take very bad initial guess, you need more time to reach the answer. But doesn't matter. But what you do, how do you stop? When to stop? Stop as and when two consecutive answers are almost same. If you're doing one more time, if you don't find any change, stop it. Cleaning and one more cleaning doesn't matter much. So then stop the process. Why do you clean unnecessarily? So clean it once or do it once, do it 3 times, 4 times, 5 times. Stop as and when you find two consecutive answers are almost same. Or just do 3 times because that is the easiest way of stopping. Or computer can be stopped. Just do 3 times, 4 times, stop the process. That's enough. So let us not quarrel about how many times you have to do. But theoretically speaking, stop as and when you have two consecutive answers are almost same. If there is no change, stop it. Why do you do it unnecessarily? Now the question is, how do you find y1? How do you find y2? No, there is no Newton-Raphson method here. How to somehow manage how the Newton-Raphson method came there. What was the reason? Newton-Raphson method was not it's not a new thing. The great advantage of Newton is he has not invented anything. He has only seen things. Invention is something, seeing things are different. He has seen it, you have not seen it. We were all blind. He was a great man. He has seen people falling. Others were also seeing but never questioned. But this man seen, oh, this is the way you are. What was his answer? Expansion by Taylor series. That's all the hint. So if you expand by Taylor series, you are going to get it as a linear structure. There is no difference between the algebraic equation, differential equation, integral equation. What is that exploitation is? You expand by Taylor series. Take appropriate term. Don't take square terms in the Taylor series. That's all the drama. So now look at the equations. So when you have equation, So you look at there is an independent variable, dependent variable. Now I am going to worry about the equation. Now, but I have to, when I say why not, please remember it is nothing to do with x. X is some independent variable. I have no control. See, moment you say independent variable, you have no control. It is independent. That is why it is independent. You cannot control the fellow who is having independent power in India, like India. But why not? It's a dependent fellow. It depends upon that fellow. So I don't care what x is. I should not touch x is good. I should not put any value for x. Moment I put x is equal to something, it is no longer equation. It is a dead body. Y at x naught is a number. Y dash at x naught is a number. So don't touch x. This is the one hint I give. Don't touch x. Moment you touch, it is independent variable. How can you touch it? If you touch, you will die. So don't touch. Put x is equal to x naught. You get a number. There is no longer equation. Never touch x if it is independent variable. So look at whatever independent variable. Don't touch that. What I do then? Now the quasi-lineation start. I start with y naught x plus c, y1, y2, y3, yn plus 1, etc. I want to find out. So I will tell you a secret. No, that's all. See, as you done the Newton-Raphson method, Newton-Raphson method was derived and then finally given answer. Xn plus 1 is equal to xn minus f of x by f dash f square. That's all the formula given. Then you taken for granted. You appreciate your teacher. That because that formula helps you to find out sequence. Same story. I will not tell you what is y1, y2, y3. I will tell you directly yn plus 1. You should accept. If you know how to find out yn plus 1, then you put n is equal to 0, 1, everything is known. So there is no need to tell how to find y1, how to find y2, how to find yn. I will tell you directly how to find yn plus 1. What a beautiful, see, great man gives in the simplest manner. Why unnecessarily wasting your time? I will tell you directly how to find out yn plus 1. So I will tell you how to find out yn plus 1. What is that you want? Sir, yn plus 1 must be solution of the given equation. Put it in that. I put it in that equation. When I put it in the equation, it must satisfy. What do you mean by solution? Solution is nothing but it satisfies the equation. So expansion by Taylor series expansion. So I write the Taylor series expansion. What is that? You both sides write expansion. So you have the yn plus 1, yn plus 1, yn plus 1. There it was same. Xn plus 1 was written in xn. So I write the Taylor series expansion about the function. Now function of how many variables? There is no confusion. My dear friend, x should not be touched. So there are 3 variables, x, y, y dash. But these two are n plus 1. Why it is n plus 1? I want the function to be satisfied. Yn plus 1 should satisfy the equation. So I downput that. So I have the yn double dash. Yn plus 1 double dash is equal to this equation. This was the equation given to me. It was the equation given to me. I wanted to find out this is the equation. This is the non-linear equation. I only said y is equal to yn plus 1 or y1, y2, y3, y4, yn plus 1. It must satisfy. Once I say it is satisfied, now I write the Taylor series expansion for this. Function of 2 variables, function of 3 variables. I am now experts. Function of 2 variables. That's why I reviewed that function of 2 variables. How to write the Taylor series expansion? How do you write the Taylor series expansion for function of 2 variables? F at certain point. Please remember, x is not touched. X should not be touched. The moment you touch x, it's like fire. You get fired. So x should not be. The moment I touch x, you are in trouble. Independent variable cannot be touched. Dependent variable only can be touched. Why dependent variable? I wanted to find out y0, y1, y2, y3. I give you generally yn plus 1. That is the reason I'm saying you can touch y, not x. So don't touch x. That's what I said. Don't touch x. So always don't touch x. Never touch x. The moment you touch x, you are in trouble. It's going to be algebraic number. It's going to be a wrong it out in solving and the problem. Now, when I go for the Taylor series expansion, what is Taylor series expansion? You have 3 variables. One variable is sitting idle, no change in that, and this is going to be in terms of the n. This is going to be in terms of n. So now I am going to write down the Taylor series expansion for the function capital F. These 2 are going in terms of the f. See, this is a beautiful way of writing it. Taylor series about a point. Taylor series about 0. Taylor series about any given point. You can always write down. So I write down the Taylor series for this. Now, when I write the Taylor series expansion, remember, I always was clever because Newton told me, don't take square terms. First term is a function at dead body. It's going to be some structure. It's not a big problem. Now, this is the structure. Next term, if I take square term will come. Square terms, I don't want to take. Moment you take square term, you are going to be, see, this is a big, neglect the second degree term. Moment I take second degree terms, what happens? Second degree means non-linear. The problem was with the non-linear. So why should I take the second degree term? You may say, sir, this is horrible approximation. This is the only best approximation in the world. There is no other approximation available in the world, because any nonlinear equation, when you do it in a linear algebraic equation, you are comfortable. Everywhere you should be comfortable. There is no way that it is wrong or right. Since there is no other way, that is the only way. Expansion by Taylor series. Take only linear terms. Take only first degree terms. Second degree onwards, kill, ignore. What happened? That's all the drama. See, this is one slide. That was the one slide. Same story. Non-linear equation is linearized by Taylor series expansion, taking only non-square terms of the top, the linear structures, first degree. So square terms we don't take. Second degree terms we don't take. Now, if what happens if you take, it becomes again non-linear. There's no point in replacing non-linear by non-linear. I think that is irrelevant here. So there is no point in replacing a non-linear function by non-linear function. What I want is, how do I replace the non-linear by linear? So a non-linear equation to be replaced by linear equation. That's all. Got it. Now I got the equation. So I have the equation yn plus 1, yn plus 1, yn plus 1, power 1, power 1, power 1. This is exactly what we call this. There is no power more than 1. I could see that if I take one more term, it will be square. See, in Taylor series, you keep writing one more term, q square, cube, fourth degree, fifth degree, seventh degree. There you may say, if you take more terms, better results. I don't want better results. I am only interested in the linear structure. You may say, sir, you are losing better answers. I am ready to lose. I am ready to lose because I can't handle nonlinear. If you take one more term, I am in trouble. Yeah, I'm worried about my trouble. You say that you take more terms. I'm not at all interested. Newton says, why should I take more terms? If you take more terms, you're going to have a highly nonlinear. Square, cube, fourth degree, fifth degree, sixth degree. This is no point. There is no point in making it as a beautiful polynomial or non-linear. So only thing is, you may say, sir, complicated nonlinear has become a beautiful nonlinear. So linear problem is important than the non-linear problem. So the nonlinear problem has become linear by simply taking the omitting, I call it as omitting the neglecting the second degree terms. Because if you take the second degree terms, it becomes a nonlinear. So you have to be very clever where to stop, how to stop, when to stop. And in all normal stand questions also, in Maclaurin series also, find Maclaurin series. You have to stop somewhere where comfortable place. Over now, that's what got it. This is a yn plus 1 dash, yn plus 1 dash, yn plus 1. So this is called the linear equation. I got the linear equation. Once I get the linear equation, now my job is simply, why should I take n equal to any value you can take? 1, 2, 3, 4 sequence can be generated like Newton-Raphson method. X1, X2, X3, they were generated, but here y0, y1, y2, y3, y4. What is the y0? I have given you y0, satisfying the boundary conditions or given conditions. Initial guess is in your choice. Once you tell me what is y0, I will tell you what is y1, y2, y3, y4 by taking n is equal to 0, n is equal to 1. So it is going to be linear for equation yn plus 1, and this is the equation for the yn plus 1. Now, nowhere you find square term, nowhere you find product. There is no product, there is no square, hence it has become the linear. For y1, y2, y3. So if I take n is equal to 1, I can take n is equal to 0, n is equal to 1, n is equal to 2. So this is a linear equation. This is the most popular linear equation, hence I call it as a linear equation. So become non-linear equation has become the linear structure. So this is then in writing compact form. So in suffix you can skip that, you say 0. Initially, these are all structures available. These are all structures available. There is no product of dependent variable. There is no degree more than 1 in the dependent variable. Hence, I could see cleverly a non-linear equation has become linear. So this is exactly what we call it as. What you wanted? You wanted the solution of this nature. So I got the px, qx is the functions. These are all px, qx structures. So I got the linear equation in terms of the clearly a non-linear equation has become the linear equation. See, idea is very simple. Only thing is we know, but we are not used. Any non-linear equation can be linearized by simply taking or neglecting the second degree term in the Taylor series. Then should we call it as a Taylor's method? No, it is not Taylor's credit. It is Newton's method. Newton has converted, exploited, and used very cleverly that if you use any nonlinear structure and in terms of the linearization, you take Taylor series expansion, take only first degree structure, then call it as a linearization. You call it as quasi-linearization or Newtonization or simply linearization at any side. So any nonlinear function can be linear as linear, or any nonlinear problem becomes linear, a nonlinear equation becomes linear. What is called linear? See, degree is 1. There is no power at all. I have removed all powers. I have removed all multiplications because Taylor series expansion is is a big weapon, is like AK-47 for a mathematician. All expansions are based on the Taylor's expansion. Anything can be replaced by beautiful structures and call it as a non-linear. Let me take a simple example. It's a simple example I have done, worked out. You can take it as, I will send the PPT to all the people. There's no problem. This PPT will be available to all the students by email also. I'll ask the organizers too. So a non-linear, why it is non-linear? Multiplication. This is not a simple equation, my dear friend. This is the most toughest example in the research called Burger equation. Those who are maybe doing research or done MSc fluid mechanics, they know it's a Burger equation or Navier-Stokes equation. It's a very popular multiplied. These two are multiplied. But this is very dangerous equation. It is not possible for any human being to solve. Take it for granted. Only now you can solve. How do you can solve? Sir, I can convert this into linear. Oh, you want to convert it? Yes, this is a conversion. So I have the conversion. I have the equation. This is the equation. So I got the conversion. I can find out what is the equation linear for y1. So y1 double dash, y1 dash, y1 multiplied by certain things, and this is going to be linearization. So how do we get this? Simply expansion Taylor series by up to first degree terms only. Second degree terms I will not take. Even if you want, I will not take. Movement I don't take. I am comfortable. I land up with a beautiful linear structure or first degree structure. Linear means first degree. Moment you take second degree terms, it's going to be non-linear. That's all the drama. Simplest definition is linear, non-linear, vertical division. Any non-linear can be linearized by taking only first degree terms. And I can, next second example, e to the power of ix. This is a beautiful example. See, it is non-linear, highly non-linear, dangerous non-linear. E to the power of y is more complicated. Why it is that way? 1 plus y square by 2, y cube by 3, y4 by 4, etc., etc. All nonsense things come. There is no end of the series. It's going to be highly non-linear. But I can convert into linear. How do I convert? Make it as this equation and then convert into f and f dash, g dash derivative, f derivative with respect to y, derivative to y dash, and I get this equation. And simply non-linear equation has become the linear. Any non-linear equation can be converted as linear. The last example, y double dash minus y square. This is also non-linear. Why it is non-linear? Because square. Product should not be there. Exponential, transcendental should not be there. Square should not be there. Hence, this is non-linear. So how do I convert into linear? I make it as find out the equation. I have the structure. I can find out the derivative with respect to y, to y dash, evaluate it at a point, and I know this is the equation what you call linear for y1. If I tell you y1, you can find out y2, y3, y4, y5. And whatever you want. So you stop the process as and when you have two successive answers are same. So any nonlinear problem can be linearized by simple logic that you expand by Taylor series. Expansion of Taylor series is not a new thing. It is already done in the maybe +2 level. You can any given function f of x plus h. You write fantastic. So stop at comfortable place. Fx can be expanded about point A, x minus A, x minus b, x minus into you know the point. So if you expand by Taylor series, take a comfortable point. Only disagreement between you and me is, sir, you are harsh to say that you stop at this place. Otherwise, you are in trouble. See, Newton is trying to help us how a non-linear equation can be linearized. If you say, I will take one more term, you take one more term, you make 100 terms. But what happens? It becomes a non-linear. So replacing non-linear by non-linear, you may say beautiful non-linear. How does it matter? There is no way to solve the nonlinear problem in the world. Whether it is ODE, algebraic equation, one unknown, two equation, two unknown, three equation, three unknown, or any equation unknowns. But what Newton said is any nonlinear function can be replaced by a beautiful linear structures. So nonlinear equation, whether it is a differential equation or nonlinear equation or algebraic equation, all nonlinear problems can be solved by linearization. So the basic essence of this problem is simplest, if you understand the simplest logic, how clever Newton was. The most cleverest person in the world was Newton. No other person. Taylor was not that great. Taylor only said you do it too. Then he never said if you stop at this place, you advantage. See, somebody should also tell me if you go by this route, okay, but somebody says at that place you have a hotel, you can eat, then I'm more comfortable. Then I can plan properly. So the Newton said, if you take up to this, you have advantage. If you take up to this, you have advantage. If you take up to this, you have another advantage. So one should tell what are the ways to going. See, keep doing. This is something wrong, no? See, you simply go like this. Somebody says, where do I get this? How do I go to Tirupati? He says, go by this way directly. Oh, how do you go? It takes long time. So Taylor series is not an answer for linearization, but exploitation, exploration, or very, very clever, what called, conceptually intellectual idea. See, the Newton was a great man, so-called father of all the entire numerical analysis. He is the man who defined everywhere Newtonization. Some of the results are fantastic. That very so simple. How is that? Nobody knows. Nobody was thought about this. Nobody was thinking about this. But Newton was a great man. He realized that any nonlinear problem can be linearized. See, solving is not a problem, but linearizing is a question. Now, that concept, once you understand, why only algebraic equations? I can go for 2 equations, 2 unknowns, 3 equations, 3 unknowns. Why only algebraic equations, even differential equations, even integral equations, even PDE, anything. Now we conclude any nonlinear problem can be linearized by simple Taylor series expansion. That is, you replace by Taylor series expansion, take only first degree term. That's a, if this secret was told you in the beginning itself in 8th class, 9th class, probably you would not have bothered about the nonlinear equation. Moment I say nonlinear equation, you are totally gone case. Oh, not only students, even teachers get confused. How do I solve nonlinear? Impossible. This fellow, nobody. Any teacher says, no, sir, I have not seen such. He has not seen, no, he's afraid of this. He's almost threatened by this equation. But now it is simple. Why it is simple? I can make it as a linear. I can always make it as linear. Even these examples, it was highly non-linear. These are all highly non-linear. It's not a simple job. X square, quadratic equation only can be solved. Cubic, 4th degree, 5th degree, no, it cannot be solved. It cannot be solved. Only Newton helped you. How Newton helped you if you understand? And then you understand, oh, he has given a path, he has given a direction, he has given a way to solve all the nonlinear problems. All nonlinear problems can be linearized by so-called quasi-linearization. This concept, if it is dumped in the BTech first year, the people will not bother about the nonlinear problems because any nonlinear can be linearized. If you linearize, then the job starts. Once you linearize, then you work out. See, now I will not teach how to solve linear problems. Why should I teach linear problems? This I will not teach. This you know pretty well. How to solve linear problems are known to you. So linear algebra is sufficient. In fact, AICT, I was a member of the AICT committee. We said linear algebra must be separate subject for entire BTech course. Entire first year, one semester, full semester must be linear algebra. You start with the matrices, teach comfortably. If you know how to solve the linear systems, any non-linear system can be dumped as converted as linear. Hence, linear algebra is enough for us. There is no non-linear algebra. There is no non-matrices or something called. So because non-linear equations cannot be written as matrices, cannot be written as a vector matrix form, but can be made it as, can now you are comfortable. Any non-linear problem can be converted as linear problem. Once I convert a linear problem, then my job ends. Your job starts. What is your job? Sir, you have converted as a linear algebra. Now you know pretty well how to solve these equations. Now I will not tell how to solve these equations. They're all simple. You may say you use Cramer's rule. I have no objection. If you have patience, you use Cramer's rule or Gaussian elimination, Gauss-Jordan, whatnot. So many methods are there. Any method can be used. That is not my problem. My problem was removing your worry. Moment you have a non-linear problem, how do you solve? Non-linear problem means, sir, no, you are in the syllabus. It's in the syllabus. It is 100% in the syllabus. Only thing is, not known to anybody, is not revealed to anybody. But Newton has already told any non-linear problem can be linearized. Hence, it is called quasi-linearization. So with this, I will stop now. This is the most simplest topic I thought. Any nonlinear problem can be linearized, whether it is algebraic equation, whether it is a 2 equation 2 unknowns, or 3 equation 3 unknowns, or 4 equation 4 unknowns, or any equation unknowns, or a different equation, second order, third order, fourth order. Any nonlinear problem can be linearized. Newton helped us in the name of quasi-linearization. So with these few remarks, I'll stop now. I think I've taken enough time. So any questions, please? Yeah, any questions? Any question? Yes, friend. Okay, no questions. Then Sudhir, I think somewhere.
Hello.
Yeah, any questions or any? Yes,
Sir,
notes.
yes, sir.
Yes, notes given to you, all of you.
Hello.
Yeah, madam.
Good evening. Good morning, sir. Hello.
Yeah, any question?
Sir, yes, sir. There is a question from
Yeah,
participant.
please. Yeah.
What if function of 3 variables and only 2 functions are given?
Where is that? No. See, it is not. See, madam, It must be consistent. If there are only one equation, two unknowns, options are more.
Yes.
If there is one equation, if x plus y is equal to 5, what are x and y? Any value is acceptable. More consistency is different, solving is different. If there is only one equation, there are two variables. One variable, the other variable is arbitrary.
Okay, sir. Okay, thank you, sir. Any more questions for the participants?
This PPT, I think I can share with you. You can forward to all the people, those who want.
Okay, sir.
If
Okay,
anybody is not getting, they can mail to me. My email address I'll give you.
Okay, sir.
Yeah, this is my email. So you can send it to me in case they want it. ynreddy@naw.ac.in. If they have any problem in this is called quasi-linearization. How do you linearize any non-linear problem? Okay. So they can mail me, or you can send, or any way they can. PPT is always available. So if there are no questions, then I can quit the meeting, or
Just 5 minutes, sir.
please.
Thank you, sir. This is Jyoti from Department of Mathematics. Now, I extend my heartful gratitude to you, sir, for accepting to be a research person of the day. You have explained us on the treatment of nonlinear problems and how to convert nonlinear into linear equation by using Newton-Raphson method. Sir also has explained us first order, second order differential equation for linear or nonlinear equation, QC linearization, and an iterative method. These topics are all very useful for all engineering branches, and the basics what you taught are very useful for upcoming research scholars, and we need your support to us in future for the educating. Sir, thank you for today. Thank you for spending your valuable time here. Now, today, we, as well as our participants, are very happy to be a part of such a knowledge-oriented session. A very great thankful to you, sir. Now, I hand over to Mr. Rudra Ravi Kumar to give vote of thanks on the end of this 3-day session. Thank you so much, sir.
Thank you.
Once again, good afternoon to all. And this is the conclusive time of our national webinar series on current trends in mathematical applications in engineering. And I personally, with feel promoting thanks from Department of Mathematics to all the 3 resource persons who affectionately accepted our request. Thank you, sirs. After that, Chief Patrons, Professor K.C. Reddy Garu, Chancellor, and the Vice Chancellor, Hemchandra Reddy Garu. After that, Dr. B. Sudhir Prem Kumar Garu, Director. Thank you so much, sir, for your acceptance of our proposal of maths webinar. Then the local administration, Mohan Krishna Chaudhary Garu, Administrative Officer, Dean of Academics, Dr. G. Ramesh Garu. Thank you for your support in this regard. After that, the organizing committee members. The first is A. Sudhir Kumar Garu, organizer, and convener Dr. J. Deepthi. And the most important person, HOD, head of the Department of Maths, RGKT, Mayor Munratnam Garu. Thank you for your coordinating work in completing and making successful of this event. Webinar of mathematics conducted by RGKT. For you people 3 only, that it became a fruitful event. and all the faculty members of the Department of Mathematics of RGKT also, I am congratulating to making this event a great and successful event. Thereafter, IT Infra, Mr. Naresh Kumar, Gnana Venkat Kumar, and Manik Kumar. Many people are there from IT Infra that we are thankful to your support in connecting the net and giving the certificates and so on. After that, for financial cooperation, I am conveying my thanks from Department of Mathematics to Finance Officer Sudhakar Reddy Garu. And then at last, thank you for guest house team in giving refreshments and so on like that. Maybe finally, thank you from Department of Mathematics of RGKT to the print and electronic media. Then I personally conveying thanks to all the participants for your enthusiastic participation in making this event a grand success. Thank you, and thank you, Ananda. Thank you, sirs, and thank you. Have a nice day. Bye. So thank you very much, sir. All the participants, we are posting a link as a feedback link as well as a certification link. So fill the feedback and make this event to grand success. Thank you, Ananda.
Shall we leave the meeting, sir? Shall we leave the meeting, sir?